So good morning and good afternoon for the folks who have joined across the globe. Today's topic is the Oracle Cloud Infrastructure security features and implementation best practices. In the next 50 to 55 minutes, we'll go across the topics. The security first design, how the OCI Gen 2 is designed from the scratch, looking at how the security from an design perspective. Then we will look at the what is the platform security they have done, and how are the secure connectivity options, operation security, and then little bit on data and application protection, what one can expect on the platform. And there's a new product launched last year called Cloud Guard, which is an innovation at the best, I can say, because none of the competitors have this particular product. And we will look at how Infolob will do the OCI security best practices, or will bring in the best practices for our customers when we are catering to. And at the last, we'll see the Q&A session and some of the OCI offerings from Infolob. So without further ado, let us get into the details. So when we talk about any public cloud, I'm not talking about OCI alone, but the security is a shared responsibility model. It's not the responsibility of the companies like Oracle or AWS and Azure, or companies like Infolob, or the end customers. So it is completely a shared responsibility. And that's where, if you see the yellow color, is the security of the cloud. So this is a predominantly when you talk about the cloud on-premise, where from the physical layer to the complete application tier, everything is managed and owned by the customers. But when it comes to the IaaS, so the data center and physical is the sole responsibility of the service provider, like the Oracle. And then comes the network, storage, servers, and OS is the shared responsibility. Why I'm saying shared is Oracle also takes care of it, but it is the end customer who has to also be equally responsible for having the security on the IaaS layer. Similarly, when we talk about the PaaS layer, virtualization and above is the shared part, and the green part is the cloud provider. And if it is a SaaS part, the data and application is the responsibility of the shared jointly by the customer as well as the service provider. So this is how, and then there is no hard and fast rule that only the cloud provider's responsibility, but most of the hacks which happens in the industry are around this yellow layered. So that's where we have to be very careful on looking at that aspect. So we know the history of OCI. So OCI, when they started, it is called the Generation 2 cloud. And unlike the Generation 1 clouds, like the ones which are existing, or Oracle has its own Generation 1 cloud called the OCI Classic. So when we talk about this, these are some of the aspects on the right side. We have new layers or new areas which are introduced in the Generation 2. You talk about the tenancy, the compartments, which are the logical isolation in the public cloud, exclusively for customers. Then we talk about the virtual cloud network. So these are some of the terminologies I'm throwing at it, but definitely there are slides where I have kept clearly what exactly they mean and all graphically, so we can look at those aspects. But there are a lot many security features being discussed on the Gen 2 point of view, which is nothing but your, and they have something called a separate cloud control computers, which is also, we will be looking at it. So when we talk about the OCI, it's the most secure for enterprises. That's because they have adopted the security first design, security made easy with strong isolation, defense in depth. We will go deep into the security first design a little later, and the comprehensive governance. Because when you talk about security, especially on the public cloud, it's not the design or it's not the security, but the comprehensive governance should be in place, saying that it is a continuous job. It's not something like I have kept it and I have designed it everything will be all right. No, absolutely not, because it is a constant governance should be in place when we talk about. And what Oracle has done is in the first generation versus the second generation, they have these server virtualization, hypervisor, network virtualization in the first generation were laying on the same layer. They have segregated it. They have separated networks and tenant environment completely separate, so that has adds a lot of security features, as well as from one tenant to other tenant, the threats will not be passed on, which is one of the fundamental designs which Oracle has done it. So when we look at a deep into the stronger security model on OCI, so it's a simple policy-based, fine-grained access where we have compartments to separate the resources. Simple policy controls everything in place. But Oracle being a very good at database, and they have the advanced security feature of Oracle database comes with many features. So what they have done it is, for the customers on OCI, they have something created a product called Data Safe, which actually goes inside your databases, whether it's on-premise or on the cloud, and they will be ensuring the things of the data masking, user access control, then user security configuration and risk assessment. It is a product which is purely works on the Oracle databases, which is the most, I can say this is the best product where we can talk about. And CloudGuard, we have a separate 3-slider exclusively talking about what exactly the CloudGuard, which is as I mentioned, it's a beautiful product which is launched recently, and none of the competition has that product, which is also one of the major components of the cloud security, I can say. And maximum security zones is a new concept they've launched, where if you create a maximum security zone, then by default, it will not allow you to do some configurations like wide open to the public. So that this is like, it automatically prevents the configuration changes if by mistake an administrator opens it wide open. And it continuously monitor and block anomalous activities. These are some of the stronger security footprint on OCI, which we will be dwelling deep into in our next slides. So what are the layers of security we see here? When we talk about any public cloud or any customer, the purpose they go to the cloud is the application. They want to run some applications. So what Oracle has done it on the OCI side is, they said, okay, application is one. Application along with the database is where we have the strongest security. And you might be running an IaaS where we have an instance. We have the instance level, many tenants of security, like the hardened images, SSH keys, certificates, root of trust, segmented signed firmware, hardware security modules. We will talk about that firmware in the next few slides. We have the virtual networks, which are completely secured. Then there is a continuous monitoring which is happening, and there are some edge services. When I say edge services, when you're going to deploy a wide open or a publicly accessible infrastructure or an application, you need the web application firewalls, DDoS protection, global POPs, and DNS security. So these are some of the areas where Oracle has a multi-layered approach for this security, which is controlling from the core to the edge. That's the concept behind this, supported by the identity federation, identity management. So this is like basically a 6-layer or 7-layer defense, we call it as, on the OCS side. Now, this slide, I'm going to take and talk more about the things. Now, when we talk about the customer isolation, and region tenancy. So any customer on the cloud will have to be launched under a specific region. Regions are basically the data centers where they live in. For example, in US, we have multiple regions, Phoenix, Ashburn, and India, we have Hyderabad and Mumbai. So every region consists of multiple ADs, availability domains, which are 3 distinct data centers. So under that region, a tenancy is the first isolation for a customer. And then the logical isolation of lob instances using compartments. A compartment is a new feature Oracle has launched, which is where we create saying that compartment for test, compartment for production, compartment for networking, compartment for security. We can have many things on those aspects. And main thing, important thing, the logical separation of a data center, like you will be having a data center for your customer. Similarly, if I want to have my logical data center on the cloud, we call it as a VCN, which is a virtual cloud network, which is a perimeter. Under a VCN, all your instances, the components, the services will be running. And you, as a customer, will be connecting from most of the areas, in the sense like from your data center, if you want to connect to the cloud via VPN or all those things, the fast connect, which is the fastest way to have a dedicated connection. These are some of the things which are very much required. So it's like you have a fast connect, and there are some gateways where you want to communicate from an internal core of your OCI to the external world. So these are some of the third aspects of the security. And we have something called an IDAM, identity and access management, group policies, OCI resource manager. These are some of the areas. If I look at it here, the identity and access management, policies, groups, resource manager, these are the logical entities which you will be assigning and governing your users on the cloud and giving them a separate roles and responsibilities for you to do it. And then the second other part comes into picture is the availability domain. Under a particular region, I told you that there will be 3 or 4 data centers, or 3 data centers maximum, 1 or 3. So you decide saying that, okay, I am having my production on an availability domain AD1, and separate instance of for maintain the availability, you put it on a separate AD2, and then you create a subnet, which is a logical separation of your networking component, saying that under your subnet, where you launch a private subnet or a public subnet. These are some of the things you launch on the network side, and there you will be keeping all those resources, like you launch your servers, application tier, data tier, and all those things. And then on the top of it, you will be having the security lists, route tables, firewalls, NSG, which are network security groups, load balancers, web application failover. These are all the security components. This is where we govern most of the security on the cloud. And then we talk about launching a particular server, which is a bare metal, the VM or encryption, the data at rest. All those other features comes into picture when we talk about. And the final part is, how are you going to monitor this? As I told you, the governance and monitoring is the continuous aspect, which you're going to do on the cloud when we say. So these are some of the telemetry, alarming, alarms, notifications, and all. So some of the dollar amounts, if you see here on some of the things, so these are chargeable, and most of them are free things, which comes along with the OCI. Some of them are like a telemetry or a notifications, very minimally charged. Fast Connect is a heavy charging, because that's where a dedicated 10 Mbps or a 1 Gbps or a 10 Gbps or 1 Gbps dedicated connectivity between from your on-premise data center to the cloud. Then web application firewall is a product Load balancer also is a chargeable, and key management as a service is another security feature. So this is where most of the security design aspects, where as an end customer, your security team is responsible for segregating or assigning these kind of policies in place in designing your aspects. And that's where Infolob comes into play, where we are masters in managing all these things. So we have done many things earlier, so we know how to the best practices and all. We help our customers in designing this security. So in a real scenario, how a reference architecture looks like. We have a customer on-premise data centers. We have a fast connect, VPN, IPsec or VPN is another concept through which you can connect. And as I told you, inside a particular AD, there will be subnets, and subnets, you can have a separate subnet for dev tier, web tier, database tier, and you can have another AD where you can have a rack standby is running on a different availability domain, and there is a data guard is being configured across two different rack instances from a availability domain 1 and availability domain 2. And the other Oracle Cloud regions, if you want to connect, OCI backbone will be used. But as I told you, the VCN is a virtual cloud network for a particular customer who is going to take care of their infrastructure within a particular region. So what Oracle has done it is, they normally gone ahead and said, we are going to use the least trust design. So who are all the components here? If you see here on the left side, the servers, the tenants, and the bottom you have the hypervisor. Now they've segregated hypervisor, the IO from the hypervisor. They have a network virtualization, which is isolated. So what Oracle has done is, it examines how to increase the layers of security checks and verification around the key areas. For example, the key areas here are the servers, tenants, and the hypervisor, which participate and communicate, talk to each other. So this is where they don't trust anyone. So that's why we call it as a least trust design, or it's a principle on which the entire OCI has been built. Now, let us see a small aspect, which is a stronger tenant isolation. I was just talking about earlier on a slide note. It is the first generation clouds, the most prevalent today. All these clouds which are available, the public clouds, they have the hypervisor and network virtualization and server virtualization, everything included. So in this aspect, what Oracle has done in the second generation is, they have removed the isolated network virtualization, has been moved away from the core of it. So the hypervisor, which was handling the network virtualization, that has been removed out, and it is isolated from the hypervisor layer. So it's a separate the network and the tenant environments. So what is the use of it? Let us see in the next slide why we have to do that. So if you see here, the threat containment, for example, there are two customers. On first generation cloud, closely observe on the left side, the yellow color ones. Imagine there is a threat which is happening. If one VM is affected, it is continuously spreading across the other tenants. But whereas the same thing happens on the second generation cloud, it will expand, the threat or the things will expand across the same tenants, other servers. But because of this isolated network virtualization, it prevents the lateral movement from one customer to the other customer. So that is where the measure, the beauty of the design aspect, why they have isolated the virtualization, network virtualization from the hypervisor layer. So this is one of the features which helps Oracle to talk about the best security on the OCI Gen 2. Now, let us see, we have security on the cloud platform. Secure the cloud platform is one thing. Identity, apps, and data on the cloud platform is another thing which we have to do it. And across the cloud, when we are talking, this is another protection and monitoring between clouds and premises is the responsibilities for a customer when he is running these particular things on the OCI. So if you look at it, what they have done it is, they even gone into the, for example, we have bare metal instances. It's like a server, we get it on the OCI, a physical server on OCI, not the virtual. That's called bare metal instance. So what they have done it here is, there is something called hardware-based root of trust. What do you mean by that? So when a server is being manufactured at the company from where it is being manufactured, not from the Oracle, but outside, for example, they will have this firmware for that particular server. Even not only the servers or any servers, you talk about the firmware will be there in your laptops, you have a firmware and all. So the firmwares, there are some things happened earlier that there are attacks like permanent DOS, a denial of service. It's like they open the back door of the firmware and then get in and infect the aspects of it. So Oracle has done saying that, oh, we don't want to do that. So what they have done it is, they have concept called gold state firmware, where firmware is which is called hardware-based root of trust, where the firmware is governed by Oracle even at the manufacturer site, so that there is no way we can have that particular losing of the trust or a firmware by some X person and Oracle Cloud is using it. Absolutely not. The firmware is also being governed by Oracle, and we call it as a gold state firmware. And not only on that, we also have it on the virtual instances. For example, if you're talking about two modes, one is the bare metal mode, you can get it a server, or a virtual server, you can get it. So both are having the hardware-based root of trust, so that nobody, even the firmware-related attacks, nobody can do that. And many of the public clouds where we have seen earlier, or the data centers where people purchase the hardware and all, this was one of the aspects. So that also being taken care by Oracle from an OCI point of view. And the other thing is, there is an isolated network virtualization we just discussed about. And the physical network and the isolated network is completely, it's like a layer 3, layer 2 kind of aspects, which Oracle has done it, segregating completely, which is helping us so that from one tenant to other tenants. But the other important aspect is they have a complete design. How they have done it here is, the customers can have the choice of bare metal or VM, fine, and no Oracle code on the bare metal. And normally it's a server, it's a hardware server. There, no Oracle code, and customer controls the host entirely. It's a customer's responsibility, and Oracle even can't see it. And Oracle personnel have no access to the host, and this is for the utmost data privacy. And they have a dedicated access control APIs and telemetry, which are completely separate outside that particular servers, which have been given to the end customers on the top. So this is another way of segregation. And the second, the design aspects, how they have done it is, for example, most of the deployments customers will be doing on any clouds is a multi-AD or availability domains, which are distinct data centers within a particular region. So for example, if VCN, we just discussed, is a virtual cloud network, and you have a subnets and subnet 2 on an availability domain. And we have the availability domain 2, again, the subnet A and subnet B. So what happens is, the architecture diagram, which I've just shown earlier, we have a database running on 180, and via DataGuard, another database is running on another AD. So how this particular, the communication happens, they have something called a MACsec encryption. What do you mean by MACsec? Is a media access control security to prevent the layer 2 security threats, such as passive wire trapping or denial of services. So this is another layer of security, and you don't need to worry about this. Is all being taken care by the environment, which is like Oracle has taken care about those aspects. And if you are talking about a multi-region, Phoenix and Hashburn are two different regions in US, and across the regions, the security is also taken care by Oracle. Now, the other important aspects, even when you talk about in the cloud or on the cloud, the identity and access management is an important factor. Network and applications to monitor those. These are some of the aspects which we as a customer or a partner can take care of it. Now, this is another example I wanted to just show you, the advanced control defense in depth and breadth when we call it as. So we have the firewalls, access controls in and out we have to configure. And this is called an internet gateway. And through this gateway only the end users will be connecting from across. If you are having a web application which is being accessed from the world, you need to definitely have a web application firewall with proactive threat detection and all. And OCI IAM, which is where we talked about how do we access control, how each user has an access to what, which server can talk to which server. All those rules and regulations have to be kept on the OCI IAM point of view. So these are some of the in-depth things which we need to think through. And for example, the identity and access management is another aspect where you talk about virtual machines, containers, object storage, block storage. So everything has to be accessed. And sometimes we need to do an automation also. So we have an OCI APIs through which we will launch those servers and all. So those also has to be configured, and access control has to be maintained for the administrators like us or an API. So it is like authenticated access when we talk about accessing these OCI services. And continuous monitoring of who is doing what, who is accessing. That's where the telemetry comes into picture to provide that audit capabilities, which is also very much requirement from a security point of view. Now, not only that, as a security administrator of an OCI, most of the world is now talking about the hybrid cloud, whether you have a data center or you have a customer, you have a public cloud OCI or a multi-cloud architecture. That's where the security aspects has to be very well looked at it. For example, this is how a typical hybrid support looks like. You have an OCI, and this OCI being accessed from on-premise servers, and on-premise you might have an AD authentication. Then we talk about the identity cloud service doing an AD bridge and doing the AD authentication. And then we have a DNS intelligence, web application firewalls. So it is like, this is a typical multi-cloud and hybrid cloud where you have on-premise data center, you have an OCI, you might be having other clouds also discussing and all those things. So this is where one has to be talking about. And this is the real hybrid cloud architecture, where we have to take care of the multiple ADs as well as FDs, the fault domains we call it as, inter-region traffic, how it is being communicating, from internet, how the traffic is driving, from the edge services like web application firewall, DDoS protection, security DNS, how this particular traffic is coming. We have local traffic, we have encrypted traffic, private traffic, internet traffic. So this is where the most of the security and network, because two things I wanted to talk here is network and security on the cloud go hand in hand. There is nothing like security is separate from the network. So these are some of the aspects one has to learn in order to control the complete aspects of a network and security on a hybrid side of the story. Now, one good thing or one important thing on the data protection is, these are some of the storage aspects on an OCI. For example, a block volume is like your hard disk of a laptop, where you actually attach block volumes to a particular logical server and then start creating your applications or databases on that. So by default, everything, the data encrypted at rest, data encrypted in transit, and customers can bring their own keys. That's the beauty of OCI. And you talk about the file storage, you talk about the object storage. Object storage is similar to Amazon S3. So everything, data, whatever you use, you don't need to explicitly do it. It is data encrypted at rest and encrypted in transit. And there is something called, if you're running a database on OCI, the transparent data encryption, the TDE, is by default comes with all the databases which are running. And we have features like data safe and data vault if somebody wants to do it. So this is another data protection on the cloud. And then once you design your OCI architecture, you're going to communicate to the external world. We can't just say, sit idle and says, our OCI only will talk to my data center. Absolutely not. You have something like a data center here talking to the OCI using a DRG, the dynamic routing gateway. We have something called network NAT gateway. So NAT gateway is basically like you have a VM running on a Red Hat or an OCI, Oracle Linux, or a database. Those servers needs to be patched. So we need to go, and those servers will be in a private subnet. So we use a NAT gateway. And we have an application web tier where it has to be accessed multi-way. We have an internet gateway. So this is ways and means how we open up those particular network gateways, configure those gateways. And this blue item as well as the red item here is the security list or network security groups, where we define what traffic is allowed in and out. So at a particular subnet layer, we configure these. So this is something you need to understand about more deep into these aspects. And this slide is like a summary slide. We talk about identity and access management is very important, which is managing users, access and policies. And we have something called OCI AM here. Multi-factor authentication, yes, we have. Single sign-on to identity providers, federation, definitely yes. So these components are basically the aspects which we talk about, the identity and access. But data protection, we just discussed about the encryption, at rest and data things. And we have data safe as a product, key management as a service. And OS and workload management, we have patch management, workload isolation. So OS management service, bare metal dedicated VM host will take care of the workload isolation. The VCN, which is virtual cloud network, network security groups, all these things will take care of the infrastructure protection. So this is where the holistic thing, when you talk about a security on OCI, these are all the aspects go hand in hand in protecting the customers on OCI. And this is where the configuration one has to talk about. Now, we will quickly get into understand what is a cloud guard, maybe 3-4 slides to talk about, and then we will see the best practices a little later. So what happened is security is the major problem for any public cloud providers or worldwide industry. And global IT security skills shortages have now surpassed 4 million, and it would take a 145% increase in the number of these professionals in order to fill the current estimated need. So what is happening is, if you see that we need a network security administrators for us to safeguard us, it will be very difficult. So Oracle, what they have done it is, they said, oh, these are the two, in order to get into this particular security problem or shortage of this particular security skills, what is the need of the hour, which is nothing but the automation. And automation should be at the scale. And we need a product which can cover all these components of OCI, which is virtual cloud network, database systems, object storage, route tables, file storage, virtual machines, containers. And what we need is the embedded expertise in it. So what exactly they have done it is, let me show you in a few more slides to talk about. So CloudGuard is a new service which is free of cost that helps customers to achieve and sustain a strong security posture on the OCI. So what exactly it does is, it not only monitors, but it applies the response. That is an important aspect here. If you see here, detect problems, everybody detects problems, fine. Check configuration, monitor activities, it detects, but it applies, correlate problems and take action immediately if the problem is identified. So that is the crux of it, where we don't need a security administrators constantly monitoring and doing it. So that is nothing but the Cloud Guard, which is a constant monitoring, plus the automation. Threat containment is also another a good feature of Cloud Guard. So can I get a view of my security posture globally? Yes, you can monitor and detect issues across global OCI tenancy. If you have a tenancy tenancy and you have regions across, like you have a servers in India and then servers in US, absolutely you can guard it. How do I identify problems from a newly created resources? CloudGuard can be applied to your root compartment and inherit every child compartment and resources. A compartment is a concept which Oracle has introduced. And do I need to create or manage my own security policies? So what happens is, out of the box, CloudGuard has already had best practices and the common security concerns, which you can use it, but you can keep on adding to that on top of it. So you can also integrate with the security and identity and access management tools and all. You can do that. And what happens, what is a language, what people talk about in a CloudGuard is, they have a targets. So targets means you say, oh, this is a compartment, I wanted to set the scope of the resources to be examined. This is a production environment, I want to continuously monitor it. This is a target. Then you put detectors. Detectors are CloudGuard components which identify issues with resources, constantly monitoring them. And if they identify the problems, they notify the CloudGuard, and what the responders, which are nothing but the bots, we can say automated bots, the responders will, based on the logic and rules which this particular recipes we configure, it stops the instance, or it suspends the user, or disables a bucket immediately, so that we don't need to go manually and do all those things. Till now, all the products in the market are more towards the detection, but not the threat containment. So that's the beauty of the CloudGuard. For example, if you see the life cycle of the CloudGuard, the bucket, users makes the bucket visible, publicly visible. So it means that there's a threat where everybody can see what is inside and get it. So configuration detector, it detected as soon as the user has done it. And bucket is a public, is a severity critical is what we have defined it. And is make bucket private? If it is yes, then it goes. And if you have configured it, saying that if any bucket you see is a publicly configurable or publicly opened, you immediately set the action. So it sends a notification, it opens an OCI functions, and responder makes the bucket visibility private. And responder is an automated bot, not a human being. And it remediates the problem immediately, and bucket is private. So this is one of the examples I'm talking about. There are hundreds and hundreds of examples people can really look into when we talk about these scenarios. And that's the beauty of the CloudGuard, which is a completely, it not only monitors and detects, so it is all based on the recipes, how much recipes you create, it will apply to that particular target. And you can also create event service and then report and notification to Slack, PagerDuty, or OCI functions, or notification email saying that this event has happened. But not only for reporting, also it will take a action immediately. So these are some of the examples of a CloudGuard where it can integrate with the third party. Now, let us see Infolob, what it has done. It is with his expertise on OCI. What we have done is we have created some of the security design best practices. Till now, we have seen the features of OCI and then the components, where exactly the security can be enabled, and the CloudGuard. But let us see the design best practices. I'm not going to go deep into all of those things, but let me give you a perception where how we do it. For example, a security design best practice for all applications which are running on OCI. So all applications, we ensure they're in the private subnet by default, so that we are safeguarding it. When you say private subnet, none of the other guys can come in. It's securely, it's a securely governed by, and all production and non-prod applications would be created in a separate subnet. So that is one of the best practices we adopt as an Infolob point of view. And we have the VMs access controlled by security list or the network security groups. These are two aspects which we control those VMs application VMs access control. Similarly, databases also, we have the same concept. Load balance is also controlled through security list and network security groups. So we categorize what is the customer running and how we do this into that particular aspect. And a customer from an on-premise to OCI wants to connect, VPN tunnel or a fast connect would be provisioned. Customer would access apps and DB through VPN tunnel or fast connect only. And apps can be accessed through internet if required through the load balancer as a service, if some apps are internet enabled. So this is where we have some governed rules, which we talk about on the security best practices. And we ask the key design questions to the customers. What's your application functionality? What is an application design? And how the application data flow goes into, how the integration happens between your application and inbound and outbound, what are the SLAs you have for your application, and who connects to that thing. All those questions will be posed to arrive at our the best practices. And other important best practices or design principles which we follow, we have a multiple compartments concept. A compartment is a logical entity. For example, in a real world, we have our on-premise world, we have something called a test environment, development environment, and production, DMZ. Similarly, we can create that for applications wise, or a network team has a separate compartment, application team has a separate compartment, database has a separate compartment. Then comes the multiple groups and users. Who are the users and who will be the administrators, storage admin, network admin, all those guys will create a separate users and separate policies so that we don't mix them up and maintain that particular thing. And if customer is in need of a multi-AD design, we design that. Then multiple VCNs. Multiple VCN is most of the customers, when we are in the financial sector, they ask us, Mr. Infolob, what's your best practices of doing the multiple virtual cloud network? I will show you in the next slides, few slides talking about those. And OCI native security design, like security rules, route tables, network security group, firewalls, all those things comes into picture. And I've told you about the internet and NAT gateways, the site-to-site VPN tunnel or a fast connect. So we have some grounding principles. We look at these areas and then talk about what design principles one has to adopt to. And even if you go further, the edge services, we call it as the load balancer as a service, web application firewall, storage gateways, and from a high availability perspective, how do we do it? If it is a multi-AD design or multi-availability domains, like 2 different data centers, how the load balancer works, how the communication across these 2 ADs will happen. All those things are the critical aspects from a network and security, which we do all those things, and we recommend even the customers to go through this. So to talk about the complex VCN design, a VCN which I've shown you earlier, it's a single VCN. Under that, we'll have private subnet, public subnet, absolutely, yes, that is one design. But most of these customers who are predominantly the banking and financial sector, and they say, I want to replicate what I am using on-premise exactly on the cloud as is. Then we come into picture saying that, Mr. Customer, you can have a transit VCN, and inside the transit VCN, we can have a checkpoint firewall where the entire traffic, the north-south traffic and east-west traffic, how it is progressing. North-south traffic is from your data center to the OCI. It will be monitored using the checkpoint firewall. So any connection from your data center comes to transit VCN. From there, using a VCN peering, it goes to the other internal VCN. This is a 2 VCN approach. Further, customer says, oh, I want multiple VCNs. For example, sorry, this is a VCN with multiple subnets. We can design that. And this is where you have a transit VCN, internal VCN, and also we'll have with multiple subnets within, which is where you just seen it. And this is another complex VCN design where customer says 1, 2, 3. You're seeing on the screen, and 4 VCNs are here where load balancer, separate VCM, application, separate VCM, database, separate VCM. And there are some customers where they ask us saying that this is where I wanted to design. And each of these VCNs, we have something called a local peering gateway. And if this VCN and other VCN on the other ADs or regions, we have a remote VCN peering. So this is where I don't want to confuse you much. I wanted to just say that this is how the real world the customer asks will be, because there is a restrict financial regulations and the requirements. So absolutely, these are all possible when we talk about. So we have like another 5 minutes. What we do as an Infolob point of view, I'll just talk about, and then we will open up for a Q&A in the chat session. So as I mentioned, network and security go hand in hand. At Infolob, we have like OCI network architecture services where we design the customer connectivity from your on-premise data center to the multiple OCI things, as well as to the other cloud stocking. In this case, it is an OCI Classic versus OCI, and we set up the design secure network, primary and DR regions, design configure the site-to-site VPN, design and configure perimeter firewalls, which we design it, implement it, and manage it. These are the aspects. And very security services, when we talk about, we talk about the secure design of the OCI services, least privilege principle IAM design, secure hybrid cloud deployments, connectivities, VPNs, fast connect, and configuring the cloud guard, the maximum security zone. CASP is another product of Oracle, and Oracle Management Cloud log analytics, log analysis if somebody wants to do it. Not only we secure design and deployment, but manage and maintain. So these are some of the aspects what Infolob brings to the table to our customers. If you're choosing OCI as a platform for any applications or anything, any workloads you talk about. And this is the gamut of services which we do to our customers, where three things: we analyze and advise the customers on the cloud assessment, discovery analysis. We help customers in migrating and modernizing their infrastructure onto the cloud. We don't only migrate as is, but we can modernize. For example, if you're running a WebLogic server on-premise, we can modernize on the cloud with a container-based architecture deployment. And if you're using a database, we can convert into an ADW, which is an autonomous database, which is completely self-managed, self-driving. So all our services here, which I'm showing you on the screen, at the bottom, we have the foundation services where architecture, networking, security, observability, infrastructure as a code, and governance. When you say infrastructure as a code, whatever we do, whatever we discussed today in the last 15 minutes, everything we automate using the Terraform or an Ansible so that we can repeat it and we don't do manual stuff anyway. And we help customers in Oracle application migrations, EBS, PeopleSoft, Banner. If you have a databases, absolutely, we talk about the database migrations combined with third-party application, because we don't just move the databases. The associated applications which are running and talking to the database will be moved, whether they can be physical or a VM. And if customers of AWS wants to migrate to OCI, we have that expertise. And AWS Aurora to Oracle MySQL, we have that services within Infolob. DR, all those aspects. But if a customer is already there on the cloud, we talk about the 24/7 managed services. And this is where we bring a lot of expertise in doing this. For example, we have something called a cloud managed services, where once we get into an engagement with you, we say, we establish the governance, we establish the change management, and automate whatever we do, which will help you to keep a cost consumption in control, ensure the availability, ensure you have the secured environment running on your OCI, and the most performant. So this is our basic cloud managed services. And we have created a tool on our own called Cloud Patrol, which is a homegrown automated monitoring tool combined with OCI Cloud Guard, which will safeguard. It's like a robot which is running continuously to monitor and notify us what are the changes you're doing it on the cloud and all. So it is part of our cloud managed services. And if you have any specific workloads like a packaged apps, custom applications, or a data warehouse, or an Exadata clouded customer, on emerging technologies and OCI, we have another package, like you can add one or more packages to the basic CMS, which is our offering on the for the customers who are already moved to the cloud. So with this, thank you very much for listening me patiently for the last 55 minutes.